This is section 2.1 for pre-calculus, and we're going to look at the quadratic function, graphing them, and putting them into vertex form. That's our main goal for today. And then be able to identify some important information. All right, here is the definition of a polynomial function. Let n be a non-negative integer, and let a sub n minus 1, and so on be real numbers. A cannot equal 0. This is a polynomial function of x with degree n, and so here is our polynomial function. So it's f of x equals a sub n of x to the nth plus a sub n minus 1 x to the n minus 1. And this just shows that your powers keep decreasing until we get down to a sub 1 n to the first, and then a sub 0, and then it'd be n to the 0 power. All right, that's your polynomial function. So more specifically though, what we're going to do is we're going to look at the quadratic. Okay, so f of x equals ax squared plus bx plus c. A cannot equal 0. This is a quadratic function. The graph of a quadratic function is a parabola. So this is our U-shaped graph opening either up, down, and having vertical stretch, vertical shrink, possibly shifting left and right, our quadratic function. Example 1, graph the following functions by hand. Describe how the graph is related to the graph of y equals x squared. See, this is the parent graph. Use your graphing calculator to check. So what we're going to do is I'm just going to show you how you would to sketch these by hand. All right. So here's our first example. F of x equals 1/3 x squared. So here's what I know about it. I know that the only thing that's changed in my problem is the 1/3. Okay. So my parabola starts here where the parent graph starts, and the 1/3. What I can do is build a little table of values like this, and I could put in 0 and I get 0. I can put in 1 and I get 1/3. And I can put in, let's say if I put in 3. 3 squared is 9, 1/3 of 9 is 3. So these give me a couple of points that I can go ahead and use. And I'm just going to go ahead and sketch this graph. So 1/3 and then 3, 3. Okay, so you can see that this one is a little wider than the parent function, and then the points are reflected about the other side. All right, there you have it. Okay, so you can build a table of values. My second example is g of x equals 2x squared. So again, we are starting at the origin. It's very similar to the parent function. And this time when I build my table of values, I'm going to get some different results. In fact, this 2 tells us it's a vertical stretch. So let's say I put in 0, I get 0 on the output. I put 1 in and I get 1 squared times 2, which is 2. And if I put 2 in, 2 times 2 squared, so 4 times 2 is 8. So it's going to definitely increase a little faster, and that would be my reflection, and so on. So this one has a vertical stretch to it. Okay, so this one up here was a vertical shrink. This one had a vertical stretch. That just reviews what the a value does to our graph. Now our third function is f of x equals 1 minus x squared. All right, so here's what I know, again comparing it to the parent graph. You may a lot of times see this being done, changing your equation around, so negative x squared and then plus 1. So here's what I know. This plus 1 shifts the graph up 1 unit. The negative x squared is a reflection. Okay, so it's going to tell us it's going to open down. You can build a table of values. If I put 0 in, I get 1. Got that point plotted. If I put 1 in, I get 0. If I put 2 in, I get -3. Now what we can do is we can reflect those points to the other side and have my parabola sketched. All right, so this reflects over the x, and it is shifted up 1. So those are the descriptions of that parabola. All right, we got one left to sketch here, and it is k of x. Doesn't really matter how your function is named. X plus 2 squared, and then plus, it looks like it's plus 3, but I think it is -3. Okay, let's go ahead and try to sketch this. So I know that the 2 and the 3, this means left 2 and down 3. I do not have a vertical stretch to it. Okay, so what I would do to build my table of values is I would put in the ordered pair -1 and see what happens. So substituting -1 in, I get -1 plus 2 is 1, 1 squared is 1, minus 3 is -2. So -1, -2, and then I'm going to put 0 in. 0 plus 2, 2 squared, 4, 4 minus 3 is 1. So 0, 1. And I'm going to reflect those points to the other side. Okay, so this one opens up, and it's been shifted. But there's your graph of that quadratic. All right, we've got what we call standard form. Standard form of a quadratic function is really what the intention is to call it vertex form. And here's that form, y equals a x minus h squared, and then plus k. The vertex is hk, pulling out your h, it's always opposite sign, and then k. So that's your vertex. The a will tell you the stretch, and it will also tell you if there's a reflection. Or not. All right, so that concludes this first video dealing with the quadratic function. In the second video, we'll actually go through examples where we will put the quadratic function into this vertex form and try to graph it and be able to state some of the most important parts.